Okay, in this video, we're going to take it up another notch with our multi-step equations, and we're going to look at equations that have no solution at all. Like, there is no possible way that this equation is ever going to, one, equal a number, be equal to itself, and it's just straight up going to be not true. So let's take a look and see what these actually look like, okay? So number one, let's see if we can see that this is no solution. So number one, we have 2x plus 5 is equal to 2x plus 1. So I'm going to draw the barrier down the wall here. Okay, so already I can see that I have a 2x on each side and a 5 and a 1. So already this looks a little strange because this 2x plus 5 can never be the same as 2x plus 1. But let me prove it to you. So we're going to start. There's one of two ways. I'm going to write this twice. We're going to go through both representations. Okay. So first I see that if I do the opposite of a positive 5, it's going to be subtracting. But I don't necessarily want to do 1 minus 5. So let's go in the opposite direction. Let's remove the positive 1. And the opposite of that is subtracting 1 on each side. Again, let's deal with positive numbers. 1 minus 1 is 0. So on this side, I have 2x plus 4 is equal to 2x. Okay. Now we need to get my variables, my like terms on each side, the same side of the equation. So this is a positive 2x, and the opposite of that would be subtract 2x on each side. Okay, I do know that 2x minus 2x is 0, so I have 4 equals 2x minus 2x is 0. 4 is equal to 0? That's not true. Okay, let's try it the other way. I took care of my constants first. Even if I did the negative 5 over, it would still end up being 0 equals 4 in that case. Let's try moving the x's this time. Okay, I have a positive 2x. The opposite of that is subtracting 2x on each side. Let's try it this way. 2x minus 2x. That cancels, so I'm left with 5. And 2x minus 2x cancels. So I'm left with 1. 5 equals 1. That's not true. Okay, y'all, so here's our new type of multi-step equations. We also have some equations that are going to have no solutions. Like, there's no way to solve this. They are not true. There's no solution that's going to have these two equations or two sides of the equal sign, or there ever be a solution to the equation, because they're simply not true. No matter what I plug in here, I'm never going to get the same thing on both sides. Ever. There's no number that is ever going to make 2x plus 5 be the exact same thing as 2x plus 1. So let me break it down to you. Let's say let's just use 2. Okay, let me plug in the number 2. No, 2 is not a solution, but again, I want to make this real. And let's use some real numbers instead of variables. Okay, 2 times 2 is 4 plus 5. 2 times, oops, I meant 2. 2 times 2, that's 4, plus 1. 4 plus 5 is never going to be this equal to or the same as 4 plus 1, meaning 9 is never going to be equal to 5. Okay, these equations are not equal to each other no matter what number you plug in, because obviously this part right here is different. If I do 2x plus 5, that's totally different than 2x plus 1. Okay, so let's try this again. Again, practice is going to make this make more sense to you. Okay, so let's try a second one. Another one. Okay. 9 times 3x minus 5 is equal to 9 times 3x plus 5. Okay, so these are almost the same equations, but there is one distinct difference. Let's see if it makes an actual difference. So let's take care of the distributive property. 9 times 3 is 27. 9 times a negative 5 is negative 45. 9 times 3 is a positive 27. 9 times a positive 5 is a positive 45x. Already, these are totally two different equations that are never going to equal each other, but let's just try it. Let's subtract 27x from each side. Okay, cancels and cancels. So negative 45 is never going to be equal to a positive 45. So this is also a no solution. Okay, let's take a look at number 3. Let's try another one. 3x minus 5 is equal to 3x plus 5. Okay, already I see that the 3x is the same, but a positive 5 and a subtract 5 is not the same thing. So let's try it. The opposite of a positive 3 is subtracting 3 on each side. So that cancels. Negative 5 is equal to, oh, that cancels too. Negative 5 does not equal a positive 5. So this was a no solution. Okay, I think you all are getting the hang of it. Let's also try this one if I was to move the constant over, which is the number or the term without a variable, just so you can see that it works even if I move the other piece over as well. Okay, so that would give me 3x equals 3x plus 10, and then subtract 3x. Subtract 3x, I get, this is 0, this is 0, and 0 does not equal 10. Okay, so I just wanted you to see that even if I move the constant over and not the coefficient and the x and the variable, that I still get a no solution. Okay, last one, y'all. Number 4. 4x plus 1 is equal to 2 times 2x plus 3. Okay, so this one may be not as recognizable, or you not easily recognized as a no solution, but let's try it. So I don't have anything to distribute or to combine on this side, so I'm just going to write it down, or x plus 1. However, on this side, I need to take care of the distributive property first. So 2 times 2x is 4x. 2 times 3, or positive 3, is plus 6x. So here I see that my 4x's are the same, but a 1 and a 6 is a plus 1 and a plus 6 is not going to give us the same answer. Okay, so let's try subtracting my coefficient and the variable over. Okay, this is 0, so 1, this is 0. 1 will never equal 6. Okay, what if I did it the other way? 4x plus 1 is equal to 4x plus 6. Okay, if I subtract my 1 over, I have 4x is equal to 4x plus 5. Subtract my 4x over. I have 0 is equal to 5, which is also a no solution. Okay, so again, on your multi-step equations, you may also see some where they're just simply not true and you're not going to have a solution to the problem. Again, I would suggest that you kind of work it all the way through, or at least you get to the point where you see that the variable and the coefficient are the same. So the 4x here, or the 3x in this case, or the 27x in this case, and the number that you're adding or subtracting happens to be different. I would, again, at least solve the problems to where they're pretty easy to recognize. So at least simplify that far if you don't work it all the way out to the end. So as each time I solved, I noticed that what I got as my answer was not equal to each other, which meant the equation was not true, which meant it was a no solution. So if you are watching this video and you are in Math 1 during the 2020-2021 school year while we were virtual learning, again, you are making sure that this examples that I just went through was on page 12 of your notebook. And on page 13, you have it listed as independent practice where you are going to show your work. Hope this video has helped. Feel free to pause, rewind, fast forward, all that you need to, and go back even at a later date when you need to review for the test. Hope this video has helped, and best of luck on your independent practice for today.